Alright. So, why do ionic compounds have high melting points and covalents have low?
I know.
Why?
Because they don't want to have low or high. So they
No.
can't be low or high.
So, let's look at sodium. So, our sodium chloride, salt. So, we have a sodium atom. We have a chlorine atom. Chlorine has 7 valence. Sodium has 1. What does it do whenever they bond? So it transfers this electron from here to here. So this makes this have a positive charge and this have a negative charge. So if I put another molecule next to it, this molecule will have a negative charge and this one will have a positive charge. They will bond. But look at here, we have a negative and a positive here. They will bond. We have a positive and a negative here. They will bond. What would happen if I put another one right here and another one right here? Well, these two will bond. But look at here, we have a positive next to a negative. And if I come over here and put one in the background, one right here, this will bond. These will bond, and these will bond.
Like James Bond.
This actually should have been backwards, but my point is that all the atoms will all bond together, making them super strong. Let's look at another one that isn't. So this is for ionic. All the atoms bond together. Let's look at covalent. So water has how many valence?
H2O. Oh.
Oxygen has how many covalent? Valence? 6.
No.
Hydrogen has how many?
Hydrogen monoxide. Hydrogen monoxide.
So, remember, hydrogen is one of the exceptions. It wants 2 around its valence, while oxygen wants 8. So if I draw a circle around here, how many does hydrogen have? 2. It's sharing these 2. It's sharing one with oxygen. Oxygen is sharing one with this. These 2 electrons are shared. We come over here and look here. We see the same thing. And if I look around here, I see 8. Now let's put another. Now, which one's more positive? Which one's more negative?
The O is more negative.
They have about the same charge. This one is ever so slightly positive, and this one is ever so slightly positive, while this one is ever so slightly negative. In a ionic one, this becomes strongly negative and this becomes strongly positive. So when another water molecule comes over here and hatches, this is only ever slightly positive. These don't want to stay linked together. There is not a true bond here. This oxygen is happily sharing its electrons with this one. It does not want to share any with the other hydrogens or other water molecules. And so what ends up happening is there is a loose bond between the different water molecules. And so it's much easier to break them apart. What is electronegativity? No. What is electronegativity? Now I'll let y'all's heads up off the desk. John? It's how strong an atom pulls on electrons on another atom's electrons. So sodium. See if I can find my paper. So sodium has an electronegativity of 0.9, and chlorine has an electronegativity of 3. That means if we take this one electron here, chlorine has almost 3 times the pull than sodium does. So it can pull this almost over 3 times as strong, and it will come over here and steal it. What about oxygen and hydrogen? Oxygen is 3.5. Hydrogen is only about 2.1. So not even double the amount. This means that oxygen can't pull that strongly on this electron. Hydrogen does have high enough strength to pull it back. So if this electron is stolen by the oxygen, hydrogen can pull it back. So what we see end up happening is covalent bonds are usually always between what? 2 types of atoms? Non-metals. That's because all the non-metals over here all have very high pulling power. If an electron is stolen, it can pull it back. So let's do Lewis dot diagram. How many valence electrons does carbon have? 4. And how many does oxygen have? 6. And they all want 8 out of these choices. Hydrogen is the only exception. How are we going to get them to bond to get 8? So oxygen wants 2 of these electrons, and carbon wants 4, right? Mm-hmm. So we can pair these off, and we can pair these off. We can pair these 2, and we can pair these 2. Such that so there's a 6 from oxygen. So let's look at how many they now have around them. Oxygen has how many? 8. This oxygen has how many? And carbon has how many? 8. And we usually represent these pairs with lines. So now count them. Each line has two electrons in it. 1, 2, 3, 4, plus these 4 gives you 8. 4 lines, each line represents 2, so 4 times 2 is 8, and we see 8 here. This is the Lewis dot for CO2. And what's the name of CO2? Carbon. Yes, carbon dioxide. And we only name it this because the EN difference. So you have to look up carbon is 2.5, oxygen is 3.5. What's the difference? The difference of En is 1. Because it's less than 1.7, we have to include the word the prefix di. And we never put mono in the front. We do for the second one. So, for example, CO, there's 1 oxygen, so we need to call this carbon monoxide. Yes, we do. We would put di. So, for example, N2O. We have to include how many nitrogen is it in here. It would be nitrogen monoxide. Yeah, we don't put mono at the beginning. That's the only exception. So, what molecule are we breathing in right now? John, lift your head up.
We're breathing in.
What mostly are we breathing in right now?
Nitrogen.
Nitrogen. It's about 80% nitrogen, 78, 80%. Why isn't that killing us?
It's killing us. Just slowly.
It's in this room. This room is mostly nitrogen. Why isn't it actually reacting with us?
Because it's a low amount.
It's a high amount. It's 80%.
Yeah, but because the oxygen is a low amount. Making it. But you breathe in a low amount.
So what happens if you leave your food out sitting in air?
It just stays there.
It's gonna get moldy. It's gonna do well. What about metal? Let's say we put metal out and it needs water. Technically, the reaction does. But the oxygen is attacking it. So the oxygen attacks and starts reacting. And Michael, lift your up.
So the oxygen.
Well, our body needs to do reactions with oxygen. When we breathe in oxygen, our body attacks the oxygen and uses it for useful stuff. But why doesn't nitrogen react with anything? So let's look at O2. That is oxygen. What does this Lewis dot look like?
2 oxygen molecules with 6 of them.
So we have, there's 1. There's the other. They're going to share electrons. How are they going to share it? So this oxygen needs how many? So this oxygen is going to share 2 with it. This oxygen needs how many? So these 2 electrons are going to be shared. So you can see this oxygen now has 8. And this oxygen now has 8. So they're happy. So I have 2 pairs in the middle. So I'll use 2 lines. A double bond, so a single bond. A single bond is 1 pair of electrons. That's 2 electrons. A pair is 2. A double bond is how many? Is 2 pairs. And a triple bond is 3 pairs. Which do you think is stronger? The triple bond is way stronger than the double. The double is stronger than the single. There is no trick question about it. It's straightforward. So imagine you're going to go bungee jumping off of a bridge. And you only use 1 very thin piece of bungee cord. Wouldn't you want to double it up? You want to triple it and keep your mouth calm properly. So it's actually very hard to break this double bond. it releases a lot of energy when you break it. What is fire? Fire is actually breaking this double bond. When you break this double bond, you release energy. And it takes a lot of energy to actually break it. So wood doesn't just spontaneously catch on fire. You have to actually get it burning first before it starts breaking more oxygen.
Is spontaneous combustion possible?
No. How many does nitrogen have? So nitrogen is a diatomic molecule. Diatomic molecule. What does this word mean? It has two atoms. Diatomic. Two atom molecule. How many valence electrons does nitrogen have?
6, 5.
5. Lift your head up, Michael.
Gee. It was sleep. Can I sleep?
No. So how are we going to pair these? What do you think it's going to look like? So look. So each one of these needs three electrons, and this one needs 3 electrons. So look at how we can pair them off. We can compare this one, we can compare that one, and we can do that one. So we have a triple bond. What do you think? How easy do you think it is to break this triple bond? Nitrogen doesn't react with anything. You breathe it into your lungs, it doesn't react with any of the chemicals in your lungs. You breathe it right back out. This triple bond requires energies like lightning bolts. It takes a lot of energy to break this bond. You don't hardly ever get this bond to break. That's the reason why nitrogen is safe to breathe in. If we actually had pure oxygen in this room, what would happen to us? We would die. You would die from oxygen toxicity. The reason why we're able to live is because we only have about 20% oxygen and 80% nitrogen. This 80% nitrogen doesn't do anything, doesn't react, and it slows down the reaction of oxygen with our bodies. Yes.
I have a question. So the moon, you say there is no.
No, talk about random stuff. Y'all going to be given a homework assignment on this on Monday. And if you don't do it, you get 0. And then we're going to have a test on it next week too.
Wait, the homework assignment is it going to last through Wednesday? You don't come to school Tuesday.
And I'm going to probably give several.
Oh, do you mean like one? Or seven? Like a couple different homeworks?
Yep, one for each day.
Can you just give me from a person? Because I don't like going. I'm going to do all of them Monday and then give them back to you. Like, if I don't have it.
I won't be here on Monday.
I won't do it. I won't do it on the No, I'm going fishing Tuesday and Wednesday. I'm one come back and do everything. I'm good fishing. Take the lunch. No, heck, no. This is my Dude, let's be on like a video chat call for like class, and then I real like a 10 times like this was just called 10 times like what? Guys, chill.
Oh, where is it? I have...
Are we done today?
No.
Okay. So,
what about this chemical? CH4. What would the Lewis dot structure look like? So carbon has 4 valence. Hydrogen has 1. Michael, lift up your head. So how many does hydrogen want around it? Hydrogen wants 2 electrons, is the assumption. So hydrogen wants 2. Everyone else wants 8. No.
Helium. I don't understand.
So we can bond these up like this.
Well, that comes to center.
So looking at more colored. So the hydrogen's coming in here. Each hydrogen has 2 dots next to it. And then we look at the carbon now has 8. So hydrogen only wants 2, everyone else wants 8. These lines count as 2. So carbon's going to have 4 lines on it. Yes.
If you have 2 columns, would that be a people bond?
What? C2, H4. Let's do that one. C2H4. Carbon will always go in the middle. So here is one carbon. Here's another carbon. So how do they go bond up? So one thing, usually it's symmetric. We can go ahead and connect these with a bond and come over here and add in 2 hydrogen. So I'm going to come over here and add 2 hydrogen to each one. And these will bond up. So what I have is, right now, a carbon attached to a hydrogen, a single dot left, a single dot right here, attached to another hydrogen, attached to that hydrogen. How many dots are around this hydrogen? So, or how many electrons are around it? How many? No, a line counts as what?
2.
2. So how many are around this hydrogen? 2. How many are around this hydrogen? How many are around this carbon? 7. Is that the correct number? No, what I say? And put your mask on. Should be 8. So what are we going to do to make it happy? No, we can't. We're doing this formula. When we have 4, we've used the 4.
Change the hydrogen.
No. There we go. This carbon has 7 around it, and this carbon has 1, 2, 3, 4, 5, 6, and there's the 7th. This has 7. So they both want an additional electron. So what we're going to do is share these 2 electrons. So we're going to end up with a double bond in the middle between these 2. And a hydrogen and a hydrogen. Doesn't matter where we put it. Another hydrogen and another hydrogen here. Now let's count them. How many are around this carbon? 1, 2, 3, 4, 5, 6, 7, 8. That was happy. 1, 2, 3, 4, 5, 6, 7, 8. That one's happy. Hydrogen has 2. As long as hydrogen has 1 line, it's happy. This is the correct Lewis dot for it. Does anyone know what C2H4 is? No.
Carbon.
Ethylene. Ethylene.
AKA
Carbon
carbon hydrate.
That's carbon monoxide.
Let's do another one. What about C2H6? So carbon will always go in the middle. Carbon will always go in center. Hydrogen will always go on outside. Mm-mm. The more electronegative atom goes in center. Unless it's hydrogen or carbon. That's basically our rules. So carbon will always go in the center. And we need to do 6 hydrogens. Let me go ahead and link these up. So I'll put 3 on that one and 3 on that one. So this is the original dot for the carbon. So we got all the carbons there. And this is the original dot for that hydrogen. This is the original dot for that hydrogen. That's the original dot for that one. Carbon has 4 dots around it. And this hydrogen has 1 dot. That hydrogen has 1 that has dots. So these are my original dots. How many electrons does carbon have around it in total? 8. So it's happy in my symmetry. You do it this way, so let's go back to C2H4. So if we link up, we have 2 carbons. Due to the symmetry, you always want to be symmetric. I'm going to put a hydrogen here, a hydrogen here, and a hydrogen here, and a hydrogen here. So that's 2 hydrogens per carbon. So where are the original dots for carbon? One's there, one's there, one's there, but we're missing one. So we need to add it back in. This one has 1, 2, 3, 4. We need to add an additional dot there. And then hydrogen has 1, hydrogen has 1, hydrogen has 1, hydrogen has 1. You cannot have a dot by itself. Not only that, this has 7 around it, and it wants 8. So we need to link these up together. And thus we get a double bond between the 2 carbons. Look at propane.
I like sniffing something.
So propane is C3H8. What's it going to look like? We're going to have to put all the C's in the middle. So I would do right now, let's go ahead and put the electrons. So we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And we can always connect a hydrogen to one of these dots. So let's do it, distribute it out. I have 1 hydrogen, 1 hydrogen, 1 hydrogen. That's 3, 4, 5, 6, 7, 8. That's what the molecule looks like. I'll show you a picture of it. Yes, propane. Of course, it's going to be bent at weird angles. But we see 3 around this carbon, 2 around this carbon, and 3 around that carbon. It does get this bent shape.
Why does it get a good shape?
Because the electrons repel each other. I'm trying to think of a good. Good molecule. Let's do this one. HCO. So rules: carbon in center, hydrogen on outside, and if you have to choose, put more electronegative in center. So what's going to go in the center? Carbon always goes in center. What's going to go on the outside?
Hydrogen.
Hydrogen. Now, what would happen if I put oxygen on the hydrogen? Hydrogen would be in the center. So where am I going to attach the oxygen?
Which one is H and C?
Then carbon won't be in the center. Again, carbon has to be in the center. So let's go and add the original dot. Michael, lift your head up and stay awake. So 1, 2, 3, 4.
No.
1, 2, 3, 4, 5, 6. And 1 right there. Oh, crap. Let's do H2CO. Let's add another hydrogen to this. There we go. So what's the next step? What should we do to fix this? It's not entirely correct. Or something else. So we can't have this lone. So how many does this have? It has 1, 2, 3, 4, 5, 6, 7. That has 7. This has 1, 2, 3, 4, 5, 6, 7. So they both need 1. What we'll do is we'll link these together into a bond. So we have a carbon double bonded to an oxygen and a hydrogen like that. Do y'all know what ozone is? What is the chemical formula for ozone? O3!
I told you.
We're dealing with nitrogen. It's in the name, ozone. So, we have an oxygen, bond it with an oxygen, bond it with an oxygen. So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, how are we going to fix this? So, this atom is going to come over here and just give this electron up, ionically. No, you can't. No. You'll see why. So let's go give that electron up. Now, how many does this have? It is 8. 1, 2, 3, 4, 5, 6, 7, 8. How many does this have? 1, 2, 3, 4, 5, 6, 7. How many does this have? 1, 2, 3, 4, 5, 6, 7. What can we do with these two electrons that are left over? And bond them. So we get a double bond here. So the reason why is if we look over here, we need this electron over here. We need to basically bond this with this one to this one. So this one was originally happy. 1, 2, 3, 4, 5, 6, 7, 8. But these two on the outside are unhappy. And they can't connect together because of the oxygen in the middle. So, in order to make this happy, it's going to need to steal one of these electrons. Another way of visualizing it is this. Let me just redo this. Another way of doing it. To really illustrate it. And that's not there. So I have 1, 2, 3, 4, 5, 6 from the original. So this one's unhappy. It has 7. So it's going to come over here and bond with this. So this electron is going to move and bond with that electron. So these two are going to pair off. Exactly. So this one now has 1, 2, 3, 4, 5, 6, 7, 8, 9. It's very unhappy. It is an extra electron it doesn't want. This one has how many? 1, 2, 3, 4, 5, 6, 7. So it doesn't want this electron, and this one does. So what it can do is just give it away. This oxygen in the middle can just give away an electron. And that's what it's going to do. The lines means the electrons are shared. It does still have the option of giving the electron away. And that's what it's going to do. It's just going to give away this electron. Let's try ammonia. CH3. Ammonium is CH4 negative. So what's it going to look like? And what? HR. Oh, H. Oh, that's wrong. That's too many hydrogen.
You can have all around it.
It's only 3 hydrogen. So what do we need to do?
So one in top left, one in top right, and one in
Usually we make it square, and it doesn't have to be, but usually we do this. So let's go back and add in our original dots. So hydrogen has 1. This hydrogen has 1. That hydrogen has 1. How many does nitrogen have? 5. So 1, 2, 3, 4, 5. So the final answer is we'll have 2 dots by itself with hydrogen. Don't forget these 2 dots. They're important.
So with any wait.
What about this one?
Carbon in the middle.
Carbon in the middle.
H on the left.
So H on the left. And what on the right?
N.
N on the right. There's two N's and two hydrogen.
You put another N on the N.
Mm-hmm.
And on the top.
Nope.
N goes on.
I should probably tell you this nitrogen's gonna go here. I'd have to tell you that. And the hydrogen goes here.
What?
So let's try doing this. Let's see why this doesn't work. Put nitrogen here, hydrogen here, and a hydrogen here. So this carbon has 1, 2, 3, 4. This nitrogen has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, how many are around the nitrogen? All right, how does it get 8? It has 5. It has 1, 2, 3, 4, 5, 6. How does it get another 2? So another one from the nitrogen. All right, so I'm going to remove this one and put it here. Oh, you cannot bond like that. You can't bond between the nitrogens. You can only do one, the central atom, whatever's in the center, can have multiple bonds, but these ones can't.
Well, it's just one bond. But if you have it the way you have on the first.
So yeah, if you were doing this, when you're doing this, you'll try this shape and you realize it won't work. There is no possible way to get this to work. Let's try over here. So 1 for the hydrogen, 1 for the hydrogen, 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
And then that nitrogen on the right would give. The nitrogen will give 1 to the carbon. You can get a double bond.
So,
This makes no sense. You get a double bond.
this one actually has 3 possible answers. So what do y'all think? So y'all said originally we bond these 2, right? So I'm going to remove them. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8. Carbon's happy. 1, 2, 3, 4, 5, 6, 7, 8. This is happy. 1, 2, 3, 4, 5, 6.
Okay, do that little circle you like.
So what nitrogen can do in this case is if these are not in a bond, this one's complicated.
It can give it away and then bond to the
So
It can get triple bond.
Can you put like one big line? Give one nitrogen to the other nitrogen.
actually I'm trying to see if this is an ion. Ions. Where's an ion?
That's nine. It's a thing with charge. I don't know how.
It has additional electrons or missing electrons. Yeah, I've explained this in chemistry, but I'm re-looking up the rules. Too complicated for this class. I don't want to go into specifics of how this can work. It'll confuse you.
It's confusing me.
Yeah.
if the nitrogen gave it one and then bonds with it?
So these two electrons are going to group up. And so if you're doing the double bond, so we're going to end up with two here and two like that. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. What's going to happen is these two dots are going to be given up like that. So 1, 2, 3, 4, 5, 6, 7, 8. That doesn't work. Because wait, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Oh, that works.
Okay.
This is the correct answer. There are multiple solutions though. So
Yeah. I was very
I
was definitely right. Here's the third one.
no, right here. Right here. It's the triple bond between the nitrogens. So you could have a triple bond here. And you need two dots around here. No, you don't.
Okay. I want to learn more physics.